So I'm going to talk a little bit about the projects now, and there are 7 altogether in here. The first one is motor performance measures. By and large, robotics today is all about DC motors, and so we're going to start off the semester by investigating the characteristics of DC motors and their performance and learn about some of the fundamental measures of that. And we do that by actually testing the motors that you're going to use with your robot. So the very first lab involves setting up a structure and writing some software so that you can measure the torque and power of your Lego motors. So that will get us started. The second one is what I call dead reckoning, and I suppose I could call this open loop control, but the idea is that you're going to build a robot and you're going to get it to drive around on a polygon trajectory around a multi-sided line, and the idea there is to use dead reckoning to move from one point to the other. And you learn a lot about building robots there, and you learn a lot about the control aspects of the robot, and that's pretty straightforward. I expect some of you have done some of these things already, but it's a really good way to get started. The next lab involves what I call reactive control, and I'll be talking in a future lecture about different paradigms for how to control a robot and what's necessary in terms of the actions and sensing capabilities of the robot. But it turns out that one of the more recent developments, although it's 1980s now, is what's called reactive control, in which the robot simply reacts to its environment, and in the process then is able to complete tasks that are assigned to it. And you'll find out that in fact the coding for this is actually pretty simple, pretty straightforward, and so it's a really good place to start. And it also gives us a chance to install some bump sensors or contact sensors and get the first taste of having the robot react to its environment. So that's a great first introduction, and we put that in the maze, as you'll see. The maze traveling is part of the course. The next one is what I call trajectory following, and so now instead of doing open loop control, you're going to do closed loop control. And so in the process of doing this, you're going to learn about probably the most ubiquitous control paradigm, which is PID control. At least in feedback control, PID is that. And so you get a chance to actually write a proportional controller, and depending on your frame of mind, you can add a integral and or derivative terms. And we're going to talk about that in class, and you'll get an understanding of it by using it. So PID control is really the basis. And along with that, the sensors that you're going to learn about are encoders, wheel encoders that actually measure the rotation of the wheels of the robot, and that really helps. Okay, so trajectory following, and then maze solving is really the next step, and that is really cool because you actually get your robot to explore the maze, learn the maze, and then traverse the maze without going down any blind alleys. And I think that's really the top of the course, as it were. And you should be justly proud when you actually get that particular project to work. So maze solving is a really big deal. No robotics course or introduction robotics course would be complete without kinematics. And so we'll give a brief introduction to the concepts of modeling and representation of robot mechanisms, and you'll get to do a little activity with that with one of our robot arms. That's so when you come out of the course, you know something about kinematics, which is fundamental to robot arms. And then last but not least is this open-ended design robot show. As I said, that's really the end of the semester, and it's a great time to show off what you've learned. So those are the projects. Here, just a flash, is the schedule, and it will undoubtedly get edited a little bit as we go along, but that's what you're looking for right this semester. And I'll give you a handout of that, and you'll also be able to find it on Blackboard. So what are the next steps? The next steps are to log into Blackboard in your account, read the syllabus and the schedule, come to lab tomorrow. This means Thursday of the first week of classes, and find a partner, and together you and the partner will go and check out a robot kit, and you can get started on Lab 1. Along the way, you should review your C programming, because everything that we write is essentially in C, although it's the Arduino C version, so it's a little specific. But if you remember what you learned in C++ or whatever course you took, that'll be a good warm-up. Okay, so next would be a discussion of DC motors, but I'm going to stop there, and we'll come back on another video. Hope you enjoyed it. Bye.